The mean value theorem states that if you have a continuous function on some closed interval AB and differentiable on the open interval AB, there exists a C in this open interval AB such that f prime of C is equal to f of B minus f of A over B minus A. Sounds like a mouthful until you recognize what this theorem is really saying. So what I've done is I've drawn a graph over here, and it meets the conditions of the mean value theorem. Yeah, we're going to say it's continuous on the closed interval AB and differentiable on the open interval AB. Now you notice that if I go from f of A to f of B, I could connect those 2 points with a line. And that line has a slope given by the change in y's over the change in x's. In other words, f of B minus f of A, the change in y's, over B minus A. That's the slope of this line. Now, up here, notice I've drawn a tangent. Well, the slope of that tangent is given by f prime of C. Notice it's lined up here with the x value of C. So the slope of this tangent is f prime of C because that's what the derivative gives us. It gives us the slope of tangents. Now what the mean value theorem says is that there is a tangent in here in this interval between A and B that's parallel to the line that connects f of A and f of B. So that's what I want to prove. That's what the mean value theorem says, and that's what we want to prove. Now, to start our proof, let's think about this line. The line that goes from f of A to f of B. We can certainly write an equation for that line using the point-slope form of the line. The slope is just f of B minus f of A all over B minus A. That's the slope of that line. The point that we'll use is A f of A. So remember the point-slope form of the line is y minus y naught equals m times x minus x naught. Our x naught is A, and our y naught is f of A. So solving for y, we get this. This is the equation for this line. Definitely. This is just the general form for that equation. So you give me a B and A, and a general rule, the function, and I can tell you what that equation is more specifically. Now, if you go up to this function here then, and I say, okay, this function is f of x, and I want to get the difference, I want to get the distance, I want from f of x down to the function, if I want to go straight down. Well, if I do that, the function that I would get would be f of x minus the equation for this line. In other words, I'll call that function g of x. So if I go from f of x minus this line, I got f of x minus this. And it's right here. So f of x, and what it comes out to be is f of x minus f of A minus the slope, x minus A. So we have this new function g of x, which is just f of x minus the equation for the line. Now what I want to do with this new function g of x is I want to put f of b in there. If I put f of b in that function, which is an endpoint here, I get this. I get f of b minus f of A minus, of course, the slope, f of b minus f of A over b minus A. That hasn't changed. But then notice I put the b in here in place of x, and I get this. I get that this b minus a cancels, and I get f of a minus a minus f of a, which is 0, and then f of b minus f of b, I get 0. So in other words, g of b, if you put a g of b in this g of x, in this function, you get 0. All the terms go out. And the same thing happens if you put in g of a. So the bottom line is g of a is equal to 0 and g of b is equal to 0. And you can play around with that if you want to and see clearly algebraically it works out. Now, we have the situation then that we have a function g which is continuous on the closed interval AB and differentiable on the open interval AB, and f of a or G of A equals G of B. So when that happens, what we have coming into play is Rolle's theorem. And Rolle's theorem states that there's a C in this interval AB such that G prime of C is equal to 0. In other words, what we have is this, that G prime of C is equal to 0 for some value of C. So let's go ahead and find the derivative of G. If we differentiate G, we get that G prime of X is equal to F prime of X minus F of B minus F of A over B minus A. That is the derivative of G. Now, remembering Rolle's theorem, we can replace the X with a C, set this derivative equal to 0, and solve for F prime of C, which means that, which involves simply just bringing F of B minus F of A over B minus A to the other side, and we get this. F prime of C is equal to F of B minus F of A over B minus A. Now that is what the mean value theorem states.